What if we don't make H 0 on the ground? What if we make H 0 something else? Can anyone else think of a place we could put H equals 0 that might be easier? Jensen. Like down here? Oh, in the middle?
Like down there.
Down here?
Yeah, like there.
So that is what we have right now. 0 is the bottom. So since it gets to the bottom, it would be 0 there. So yes, that's what we're doing right now. Any place other than the ground that you might want to do 0? What do we think? What do we think? What do you think, Joella? All right, I like it. Let's start at 0. Instead of ending the ground at 0, let's start A at 0. So what is this going to change? Is this going to change my height at A? Yes, because my height at A was 4 meters above 0, but now height at A is 0. So height at A is 0. My height at B was 3.5 meters above 0, but now my height at B is 0.5 meters under 0, so it's negative 0.5. My mass has not changed. My mass is still 0.5. My velocity at A has not changed. I'm still starting at rest. But my velocity at B is still what I'm solving for. So the only things that changed were my heights. So I'm going to go back and I'm going to reset up my kinetic energy and my potential energy, and we're going to see how, if at all, they changed, and if that is actually easier or not. It's going to be easier mathematically if it makes sense to you. If it doesn't make sense, then do it the way we did it in purple. But if it makes sense to you, this is going to be easier mathematically. So the kinetic energy at initial is still 1/2 mv squared 0. But my potential energy initial has changed now. So my potential energy at A is mgh, just like the equation was before, but this time my h isn't 4, my h is 0. And now you can see why the math is a little bit easier. Where I had 19.6, it's 0 this time. So there's one less thing to worry about. Okay? Do my final kinetic and my final potential. My final kinetic is still 1/2 mv squared. That hasn't changed, so it's still 0.25 v squared. And my final potential energy is going to be different. It's still mgh, but the h is negative 0.5 this time. So that's going to give me negative 2.45. So if I set this up, I get kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. But my potential energy final is negative 2.45. So I'm going to add 2.45 to both sides. Gives me 2.45 equals 0.25 v squared. I'm going to divide both sides by 0.25. Gives me 9.8 equals v squared. Square root both sides. And you get v equals 3.13. Oh my gosh, it's the same answer. It does not matter what you make h0. So pick what's easy for you. Pick what's easy for you. If making the ground 0 is easy for you, make the ground 0 every time. If that's easy for you, do that. But if it makes sense to you, hey, what if I made something else 0 so that I have an energy value of 0 that I wouldn't have otherwise, then do that. So Joella was talking about picking A to be 0. That made PE initial 0. And it had one less value I had to worry about. Over here I had three values, 19.6, 0.25 v squared, and 17.15. Here I only had two, 0.25 v squared and negative 2.45. If it was me, I would have picked b to be 0. I would have made b 0. So I ended at 0 and started at a. If you want to, like, if you're like feeling particularly snappy one day and you're just like, hey, I'm going to make height of 1.50. I mean, you could do that. It would be more complicated, but you could do that. So you can pick anything you want for 0. Yes?
I don't know how, like, so is kinetic energy the first one, first hill, and then potential is the second, or like, I don't know how you know where you get the numbers from.
Okay. So the equation is total energy initial equals total energy final. So the total energy is your kinetic and potential at A, and your final is kinetic and potential at B. So I found these two values by doing 1/2 mv squared for kinetic energy, which is the equation up here. And I did mgh for potential energy.
Initial's the first hill.
Yes. Yes. And final would be the second hill. So you kind of have to read through the problem and figure out, like, what are these initial and finals going to be. So, like, for this problem, you might think the bottom is final, but it's not talking about reaching the bottom. It's talking about going back up to the top of the second hill. So that's why I made final here and initial here. Does that help?
Yeah.
Okay. Sweet. All right, let's look at the back page real quick, and I'm going to give you time to work. Oh, yeah, we're in good shape. So, on the back page, you got two problems to work on here. Okay? So, starting for rest, a child zooms down a frictionless slide from an initial height of 3 meters. What is their speed at the bottom of the slide? Assume she has a mass of 17 kilograms, and at the bottom of the slide is 0.5 meters above the ground. So, you can make the ground 0 if you want. You can make the bottom of the slide 0. You can make the top of the slide 0. You can make the middle of the slide 0. You can make whatever you want 0. But make something 0 and make sure to label it. Okay? Also label your initial and final. Again, I've been writing it as A and B, but you can write it however makes sense to you. If you want to write it I and F, if you want to write start and finish, however you want to write it is fine. And then the second one is a 0.5 kilogram Hot Wheels car is given an initial velocity of 2.1 meters per second, zooms up a ramp. How high will it go before it stops? So this is going to start on the ground and end up higher. So you want to figure out how to solve that one. So again, draw a diagram, label your knowns and unknowns, set up and solve, and see what you can get. So go ahead and work on those two practice problems. I'll leave my example up here for you to look at. Okay? And then I'll give you time to work here and see what you can come up with, see what your answers are, get your stuff checked, figure out what's going on, and just kind of see what questions you have and what you need me to answer. So go ahead and work on the practices, see what you can do. And I will come around and check, see how you're doing.